Okay, this review problem is like 12.25 from the homework set. The difference is that I changed the direction of the direction and the angle of this force. Okay, so I think the other one was coming at 45 degrees, slanted the other way. Okay, so with that change, let's go ahead and solve this problem. Okay, so I've already drawn the free body diagram. You should think about that. In this problem statement, we were given that the beam is uniform. Okay, so read this here. The beam is uniform and has a mass distribution of 45 kilograms per meter. Okay, so it's a two-dimensional model. And so all you need to know here is the length. And if you know the length and they give you the mass per length, you can figure out the total mass of the beam. Okay, so the mass of the beam, we'll call that cap M, is going to be 45 kilograms per meter, and then we see that the beam is 16 meters long. Okay, so that gives us the mass of 45 times 16. Okay, so this weight, the W quantity, would be 45 times 16 times gravity. And this would be in newtons. Okay, so that's one of the things you need to know. All right. From there, we are interested in finding the reactions that supports A and B. Okay. Now I reference B back to the right because I could tell that the force here was pushing it back to the left, so I know that B has to counteract that. Okay, and like we've done several times, we're going to need to figure out sum of forces in the x direction, sum of forces in the y direction, and the sum of moments. Okay, so to get started with that, we just need to cut this part out here and talk about it. Okay, so I got too much there, but basically what I need to know is here's this horizontal. I want to know this angle, okay? And what I know is that this is down 3 and over 2 from the picture. So if this is the angle theta, okay, then theta would be the arctan of 3 over 2. Okay. And so the reason this is useful is because eventually I'm going to need to break the force component into an x component and a y component. Okay, so let's write the equations. Sum of forces in the x direction with moving to the right is taken as positive. Okay, so we have sum of forces in the x direction. The A force is vertical, so that doesn't do anything. Then we have the 5K force, K being 1,000 here, 5,000. I'll just write that down so that it's clear to everyone. Substitute the 1,000 for K. All right, so 5,000, and then if I want the horizontal component of that, that would be cosine of theta, where I've already calculated theta. Okay, now that's working back to the left, so I would need a minus sign. Okay, then I have plus bx, and those are the only x component forces, so that's equal to 0. Okay, so I can quickly solve for bx, 5,000 cosine theta, and I think I worked that out already. Hold on. Okay. Okay, so I get, sorry, trying to find it. I get that Bx is 2,663 newtons acting to the right. Okay, so there's one of the reactionary forces. Okay, now we need to do sum of forces in the y direction, taking up as the positive. Okay, so we see, we have A, and then we have W, and then we have to resolve the 5K into a vertical component. And of course we have B. All right, so A is positive because it's moving up. Then we subtract the weight W, we add By, and then we have, working down, the 5,000 times the sine of theta equals 0. Okay, so what's known? W is known. Okay, so we know that from here, so we can substitute that number for W. This is known because we know theta. Okay, so all that's left is solving for A and By. Okay, but that's one equation. We have two unknowns, so we need another equation. Okay, so sum of moments about a point. Let's do it about point B. It doesn't really matter. You could do A. It's about the same amount of work. All right, so we're doing about point B, and so about point B, I have a moment generated by W. Okay, that would be in the counterclockwise direction, so that's what we're taking as positive. So this would be W times the length out to W. Okay, if the total length is 16, the midpoint is 8. So W times 8. All right. Then we have A creating a clockwise, A is pushing up, so that would create a clockwise rotation. And so that would be minus A times 16. Okay. And then the 5K force pushing at the angle, the vertical component of that would be plus 5K times the sine of theta. Okay, and that would be acting counterclockwise, so hence the positive sign. And let's see, you get it. The horizontal component does not generate a moment because it's acting in the same direction as the moment, perpendicular to the moment. Okay. All right, so all that's equal to 0. What's known? Well, what we know is, sine, we know theta, so we know that number. We know W, and so we can solve for A. All right, so when we solve for A, I did that, and I've got A is equal to 6,773 newtons acting up. Okay, and then from there you can plug A back in up here, and you get where you can solve for By. So By in this case is 4,277 newtons acting up. Okay, so that's it for this problem.